Hey everyone, this is Bradley Bush again with another algebra video. Today we're going to talk about the most common function graphs in algebra. Our to-do list, the first thing we'll do is discuss the 7 most common function graphs. I'll show you some pictures of them, and then for each of them we will discuss the domain, range, symmetry, and whether or not the function's increasing, decreasing, or constant, and on what intervals we find those properties. So let's start. Here we go. If you're in algebra then of any sort, then it's very likely you'll see some of these functions, and probably most of these functions actually. So here's some very common graphs to see in algebra. The first graph we have here is called the constant function. It's just a horizontal line, so it's y equals and then some constant. Here I have the constant represented by c, but c can be anything. It can be 5, it can be 1.2 or 1.5, whatever you want it to be. The domain for this constant function is all real numbers, and the range is just a single value, which is the y coordinate on any of the points on this line. They all have the same y coordinate, and it is constant on all real numbers. So from negative infinity to positive infinity, it stays constant. It's never decreasing or increasing, and it is an even function. So it has symmetry about the y-axis. All right, the next function, the identity function. This is y equals x, or f of x equals x. So any point along here, the x and y coordinates are identical. So 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. It's a perfect diagonal. The domain, all real numbers. The range, all real numbers. And it's always increasing. So it's increasing from negative infinity to positive infinity. And it is an odd function, which means it has symmetry about the origin. The third graph we have here is the absolute value function, which looks very much like the identity function, but if you take the left side of the graph and flip it up above, flip it over the x-axis, then that's what you get. So it's really kind of like the identity function, but all of the outputs are forced to be positive. And that's where the absolute value comes from. So it's the identity function, but with absolute values, so the negatives are forced to be positive. The domain is everything, all real numbers, and the range goes from 0, including 0, to positive infinity. You don't see anything in the negative area because of the absolute value. It's decreasing from negative infinity to 0, and it's increasing from 0 to positive infinity. And it is an even function, so it has symmetry about the origin. About the y-axis. Function 4, the quadratic function, you probably have seen this. It's often called a parabola. It has a vertex here at 0, 0, and then goes up to the right and left. And the functional form is y equals x squared. The domain is all real numbers. The range starts at 0 and goes to positive infinity and includes 0. It's decreasing from negative infinity to 0 and increasing from 0 to positive infinity. And it is also an even function. You can see that it has symmetry about the y-axis, or in other words, it mirrors the y-axis. You can fold it over the y-axis and have a perfect match. The square root function is function number 5. Starts at 0, 0 here and then goes up to the right. The domain then is 0 to infinity, including 0. The range is 0 to infinity, including 0. And it is increasing from 0 to infinity. And it is neither even nor odd. Function number 6, the cubic function, so x cubed, y equals x cubed. It looks kind of like the square root function on the right, where it goes up kind of like a parabola, it goes up a little bit steeper than the parabola because your inputs are cubed instead of squared, so they rise or get larger faster. But on the negative side, the negative inputs remain negative because when you cube a negative number, it stays negative. So instead of going up to the left like the square root function, it comes down to the left. So domain, all real numbers. The range is also all real numbers. It's increasing everywhere from negative infinity to positive infinity. And it is an odd function, so it has symmetry about the origin. Our final of the fabulous 7 most common functions seen in algebra is the cube root function. So the functional form is the cube root of x. Here you can see it passes through the origin and comes up, kind of like the square root function, and then comes down to the left, which is not like the square root function. The square root function doesn't have anything in the negative side because it's not defined there, but the cube root function is defined in the negative side of the x values. So domain is everything. The range is also everything because it continues to go up as it goes to the right and continues to go down as it goes to the left. It's increasing or has a positive slope everywhere, and it is an odd function, so it has symmetry about the origin. That's it. Hope you enjoyed the video and hope this is useful. You'll probably see these functions. You will often see these functions transformed and moved around somehow on the graph, but these are this is the base that all of the functions will start from. Enjoy your mathing, and thanks for watching.